So I suggest every problem that you use the quadratic formula, you write it out and you get used to writing it out so that you get practice memorizing it. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So, example 1. Solve the equation 0 is equal to 3x squared minus 4x plus 1, and thus find the x-intercepts of the function f of x equals 3x squared minus 4x plus 1. Okay, well, you could try to factor that, or you could try to complete the square, but for us, A here is 3, B is negative 4, and C is equal to 1. So x equal to negative b plus or minus the square root of b squared minus 4ac all over 2a is negative 4 plus or minus the square root of negative 4 squared minus 4 times 3 times 1 all over 2 times, 3. So this is a positive 4 plus or minus the square root of 16 minus 12 all over 6. So watch out for those of you that are a little shaky on your algebra and how you simplify this. First of all, this is 4 plus or minus the square root of 4 over 6, which is 4 plus or minus 2 over 6. You can rewrite this as either 6 over 6 or 2 over 6, which is 1 or 1/3. And so this means that 1 comma 0 and 1/3 comma 0 are the x-intercepts for this quadratic function. So, does anybody have any questions on that? Okay. Example 2. Find the x-intercepts for f of x equals x squared plus 4x plus 13. This is an important exercise on this one. You may feel like I'm about to do the same thing for repetition. The outcome here is very different. Please pay attention. Let me know if you have any questions here. Find the x-intercepts for this function. Well, here we go. That means that f of x equals 0 if x squared plus 4x plus 13 equals 0, in which case a equals 1, b equals 4, and c equals 13, excuse me. That means x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a, which in this case is negative 4 plus or minus the square root of 4 squared minus 4 times 1 times 13 all over 2 times 1. And this is negative 4 plus or minus the square root of 16 minus 52 over 2, which is -4 plus or minus -36 over 2. And we have a real problem here. The square root of -36 is an imaginary number. And if you're not familiar with that, that's okay. We're going to deal with that a lot later in the course. But this has no real x values. These are complex numbers. This actually turns out to be -2 plus or minus 3i. And while, so what does this mean? This means that the quadratic equation 0 equal to x squared plus 4x plus 13 has answers that are complex, but the function f of x equals x squared plus 4x plus 13, the parabola, has no x-intercepts. That is to say, this parabola never actually touches the x-axis. So what's going on here? Well, if we look at f of x equal to x squared plus 4x plus 13, and we had completed the square on that earlier, that's x plus 2 squared plus 9, and we graph that, the vertex is -2, 9. 2, 3, 4, 5, 6, 7, 8, 9, which is right here. And I'm going to have to actually move this down some. This is, oh, oops, undo that move. This is, stop it. This is our x-axis. This is our y-axis. And our parabola actually opens up like this. And what's going on here is there are no x-intercepts. This graph opens upward, and then it was shifted upward. It's impossible for this to have any x-intercepts, that is to say, no real, what we call roots. So as far as intercepts go, as far as x-intercepts are concerned, there are 3 outcomes possible. Probably one you're most familiar with is having a parabola cross the x-axis in 2 spots. So this is 2 x-intercepts for f of x, or 2 real solutions to f of x equals 0. And it doesn't have to open upward. It can be a parabola that opens downward as well. Up or down, doesn't matter. In each one of these scenarios. The second possibility is that the vertex actually lies right on the x-axis. This is 1 x-intercept for f of x. or f of x equals 0 has one solution. Up or down. Could have been either direction as well, right? It could have been something that opens downward as well. And then in the last scenario, which is what we just looked at, this parabola could open upward and be above the axis, or it could open downward and be below the axis. And in this situation, there are f of x has no x-intercepts, or f of x equals 0 has two complex solutions. So those are the three scenarios. So how can we tell which scenario we're in? Well, actually, all of that is related to the quadratic formula and what's called the discriminant. So let's talk about what's called the discriminant. The discriminant is the part of the quadratic formula underneath the radical. So this is from the quadratic formula, x equals negative b plus or minus the square root all over 2a, and this is just simply the piece under the radical. Now, why is that so important? Well, these three situations are completely determined by this discriminant. It discriminates between these different situations because if b squared, so option 1, which is directly related to picture 1 that I have up here, if b squared minus 4ac is positive, then x is equal to negative b plus or minus the square root of a positive number over 2a, and this is negative b plus or minus some other number over 2a, in which case this is two real answers, and we have two x-intercepts. Option 2, which is this second scenario, is if b squared minus 4ac is equal to 0, then x is equal to negative b plus or minus the square root of 0 over 2a, which is just negative b over 2a, and there is one real solution, which means that there is one x-intercept, or the graph touches the x-axis one time. And then finally, scenario 3, which is this guy up here, is b squared minus 4ac is less than 0, negative, and this gives us x is equal to negative b plus or minus the square root of a negative number over 2a. And the issue here is taking the square root of a negative number, and so this has no real solutions. It's not that it doesn't have any solutions. The idea here is that it has no real solutions. It means that they're complex, but that translates to no x-intercepts. Does not touch the x-axis. And so all of these three scenarios, I don't know if I'm going to be able to fit this all on one page here. All of these three scenarios are then dictated completely by what's underneath the radical on the quadratic formula, this discriminant b squared minus 4ac.